Greetings, Mr. Sutton here, bringing you the AB Calculus 3.8 Extra Practice number 3 solutions on implicit differentiation. For number 9, y is going to be a huge pain to try to isolate here, so let's use impdiff for this derivative. So we'll get 3x squared plus, let's do product rule for that 3xy term. So I'll use 3x and y. Derivatives are 3 and dy over dx. So we have 3y plus 3x times dy over dx. Moving on, we've got 6y squared times dy over dx equals, that 17 turns into a 0 when I take the derivative. Let's subtract these two terms that don't have dy over dx's over to the right side. Now that I've done that, I can factor a dy over dx out of the left side, leaving me with 3x plus 6y squared inside of parentheses. And then if I divide both sides by that, I get an answer. Now, since this is multiple choice, you have to match it with something they gave you. So a few things we can do to clean this up. We could divide everything by 3. That would give us negative x squared minus y over x plus 2y squared. That at least has the same coefficients as the answer choices. And one more thing we could do, you'll notice a lot of these answers have negatives out in front of the fraction. If we factor a negative 1 out of the numerator, we can turn this into negative fraction, x squared plus y over x plus 2y squared, which would match answer choice A. For this problem, we want the derivative of this curve at x equals 2. Let's start by taking the derivative of this thing. I'm going to use implicit differentiation here because y is going to be kind of annoying to isolate. So we've got derivative of x squared, which is 2x. xy is going to require the product rule. We have factors of x and y, derivatives of 1 and dy over dx because we're using impdiff here. So multiplying that out with the ribbon, I've got y plus x times dy over dx, and that all equals the derivative of 10, which is 0. Let's keep x dy over dx on the left side. Let's move 2x and y over to the right side. So negative 2x minus y. And then to get dy over dx by itself, just divide everything by x. At this point, we have to plug in 2 and some y value. Which y value? I don't know. Let's plug 2 into the original equation and see what y value goes with 2. So we've got 2 squared plus 2y equals 10. So let's see here. 10 minus 4 is going to be 6. Divide by 2, you have y equals 3. So we're actually plugging in the point 2, comma 3 to our derivative. So that's going to be in our numerator, negative 2 times the x value 2 minus the y value 3, all over the x value 2. This is negative 4 minus 3, which is negative 7 actually. And then we have 2 in the denominator, so negative 7 halves, which is answer choice A. For this problem, I'm trying to find the slope of the tangent line, also known as the derivative of this curve, at the point 3, comma 2. Let's go ahead and differentiate this using implicit differentiation, since y is impossible to isolate. On the left side here, we've got 6y for that derivative with a dy over dx tail, minus, this will just be 4x for that derivative of negative 2x squared, equals, derivative of 6 is 0. For derivative of negative 2xy, I need the product rule. So using the box and ribbon, I have factors of negative 2x and y. Derivatives of negative 2 and dy over dx. Using the ribbon to multiply it out, this is going to be negative 2y minus 2x dy over dx. All right, let me get the dy over dx's on the left side and everything else on the right. So I can add this 2x dy over dx over here to the left side. I still have a 6y dy over dx over there. On the right side now, I have the negative 2y that was already there, and I'm going to add this 4x to get it over there. Now I can factor out a dy over dx on the left side, leaving me with 2x minus 6 or plus 6y inside of parentheses. Dividing all that out, we've got negative 2y plus 4x over 2x plus 6y. I could reduce that if I wanted to, but I'm just going to be plugging 3, comma 2 into all of this anyway. So, half a dozen of one, 6 of the other. So in my numerator, I've got negative 2 times the y value 2 plus 4 times the x value of 3. Down below, I have 2 times the x value, 3, plus 6 times the y value, 2. Back in the numerator, this is negative 4 plus 12, which is 8. Down below, we've got 6 plus 12, which is 18. 8 over 18 can reduce to 4 over 9, which gives us choice B. For number 2, we want the derivative of this equation. Because it's difficult to isolate y, impdiff is definitely the way to go on this. Going left to right, we've got 2x plus 2y times dy over dx times dy over, or plus dy over dx, derivative of y. You could also write y primes instead of these dy dx's, equals derivative of 4 is 0. All right, so let's move all the stuff that doesn't have a dy over dx over to the other side. So we'll subtract the 2x. Now I can factor out a dy over dx, leaving me with 2y plus 1. And if I divide by that, I now have dy over dx all by itself, so negative 2x over 2y plus 1, final answer. To find the derivative on this one, I'm going to use a little impdiff. Y is all over the place, so I'm not even going to try to isolate that. Going from left to right, derivative of 3x is 3. This minus 2xy term, I'm going to need the product rule for that. So using my box and ribbon on this, I've got factors of negative 2x and y. Derivatives are going to be negative 2. And since this is impdiff, dy over dx. Next, derivative of y is, well, actually, let's multiply this out and write it out here. So we've got negative 2y minus 2x dy over dx. All right, derivative of y, that's dy over dx. This is going to equal the x squared derivative, so 2x. And then derivative of y squared is 2y with a tail of dy over dx. Let's get dy over dx's on the left, everything else on the right. So I've got my negative 2x dy over dx that can stay over there, along with the dy over dx that's already there. I'll subtract 2y dy over dx to get that on the left side. On the right side, I've got the 2x that was already there, and I'm subtracting 3 and adding 2y to get those over on the right side. On the left, I can now factor out a dy over dx. That leaves me with negative 2x plus 1 minus 2y. Dividing everything by all that, I've got 2x minus 3 plus 2y, all of that over negative 2x plus 1 minus 2y. On this problem, to find the derivative, I'm going to need to use implicit differentiation since I can't isolate y. Going from left to right, derivative of x is 1. Derivative of sine of y, that's going to be cosine of y times dy over dx, since y is treated as an inner function here, so we're using the chain rule, equals, well, xy, I'm going to need the product rule there. So I've got factors of x and y, derivatives of 1 and dy over dx. So multiplying it out with the ribbon, that's going to be equaling y plus x dy over dx. Let me get the dy over dx is on one side, everything else on the other now. So this cosine of y dy over dx, that can stay on the left. And I'm going to subtract this x dy over dx to get it over there. This is going to equal, on the right side, we have the y that was already there, minus this 1 that I'm moving over. Back on the left, I can factor out a dy over dx, leaving me with cosine minus x, or cosine of y minus x. And that can now get divided, so I have y minus 1 over cosine of y minus x, which gives me my final derivative.